Hey guys, this is Carrie, and this is the introduction to the Create Task video for those of you that were absent or maybe found it a little bit challenging to follow the project guidelines. So, the Create Task is part of your AP exam, and so this is due on the 30th of April. And the idea is this is, oh, and also, sorry, just because it's this year and the COVID-19 thing is happening, this is worth 60% of your AP exam. Um, so the other 40% of your AP exam, this is a change from normal years. The other 40% is from something called your Explore task. But we're going to talk about that starting Wednesday or Thursday, depending on which block you're in. So this part is worth 60% of your AP exam, big chance for college credit. But it's also like the coolest project of the entire year in my eyes because it's your first opportunity to really like in depth spend a long period of time creating something of your own design using the code that we've learned this year. So the number one thing that you need to keep in mind is that this is your chance to create something of your own design using code. Now that can be a little bit overwhelming sounding. So the two options that I'd like you to keep in mind is, if it sounds interesting, you can totally just start from a blank Sublime text page like this and start coding away whatever you want. So code from scratch on your own. An alternative to this that you could do is either using a video that you found online, somebody else's video, maybe one of our videos, or using a project that we completed together. Code an established project. So an example of that might be the game that we just did in Unit 7. So take an established project, and that could be a project we did together or a project that you do independently by watching somebody else's videos on YouTube, maybe Wes Boss, because we watched some of his videos in class, and then add some features of your own. Now, key phrase here is of your own and on your own. The idea here is that you're not just programming something following along with somebody else's video. You're actually taking a moment to create something on independently that somebody isn't showing you how to do, that you're putting your own creative spin on. So that sounds pretty open-ended still, but there are a couple of guidelines that they have in order to help you do this. But before we look at those guidelines, I wanted to show you a couple of examples of this. So one example of the code from scratch on your own would be, I made, just as this started, I made this simulation of the spread of a virus, and I've shot a couple of videos about it. But this was a create task thing that I coded on my own. It was, all right, so it's a simulation of the spread of a virus. The red ones are infected, the blue ones are healthy, the green ones are cured, and the black dots are dots that were infected for so long that they ended up dying. And it simulates the spread of a virus by having these dots bounce around. It's a little hard to see just out of the blue. But the idea here was this wasn't a project that we worked on together. This was something that I created completely from scratch on my own, and this would satisfy the create task. An alternative to this is we also all created the game file. And so you can actually start with that as a template. So if you drag the game file over, all of us created the game file. But I actually, to build on the game file, I added a new feature, which is these bombs. And the way that those bombs work is if the enemies touch those bombs, then they'll explode. And so this is also allowed. This is the second option, which is take an established project and add some features of your own creation. Now, in terms of stricter guidelines, the features that you add is you need two major feature requirements. And they are our two most important words in the class, which are an algorithm of your own design and an abstraction of your own design. So let's review these separately. For the algorithm, you have to first remember what an algorithm is. The definition of an algorithm is it is a step-by-step procedure or a recipe to do something. So an example that we've looked at in the class in the game file is a step-by-step procedure that we have here is the step-by-step procedure to find the distance between two different sprites on the page. Another example of an algorithm, a step-by-step procedure, would be the step-by-step procedure to generate a random number. Now, neither of these algorithms is actually sufficiently complex for the create task. The create task requires that our algorithm is, for the create task, the algorithm needs to contain two sub-algorithms. And those are exactly what they sound like. Basically what this is it's a big procedure that contains at least two smaller procedures. So from our game file, a good example of that would be in the food item. If we look at this update method contains two smaller procedures. One of them is to find the distance between the player and the food item, and that's actually running this procedure right here, the getDistance procedure. But it's also running a secondary sub-procedure, which is if the distance between the player and the food is less than a certain amount, it's running through this set of steps, which is to pause the sound, start playing another sound at 0, and then play the bad sound. Oh, and this is the wrong one, sorry. This is the one for food. For food, it was to increase the score, generate a new location for the food, and then create a new monster, play a good sound. So here's the second sub-procedure, sub-algorithm, and here's the first sub-algorithm. Sorry about the confusion. All right, so an algorithm is a step-by-step procedure. Now, an abstraction is a tool for simplifying the structure of your code. And it's something that hides complexity within the simplification. So an example of an abstraction is when you tie your shoes. That also happens to be an algorithm, right? There's a step-by-step process for tying your shoes. But the abstraction element of tying your shoes is when you tie your shoes, you don't think about the individual steps to do it. You just think about it as this overall process tying your shoes. And by thinking about it as this overall process tying your shoes, it actually makes your life a lot easier because you don't have to remember the individual steps, because tying your shoes is a clear name for what you're doing, as opposed to something like pull the laces. That's not really very clear what exactly the end intention is there. So this name, tie your shoes, would be an abstraction that we use in daily life because it hides the complexity of that task, tying your shoes, and it allows you to mentally have a simplified version of it as well as have a simplified name for calling it. We use the same ideas in our code as well. So one example of this in our code is getting the distance between two objects on your screen in the game, two characters, the food and the sprite, or the player, the food and the player, is a really complicated procedure. You have to find their x and y coordinates, you have to plug their x and y coordinates into this distance function, you've got to return the distance. But rather than thinking about all these complicated steps, we can just think about this as, hey, we're getting the distance between the two different sprites. So getting distance happens to be an algorithm because it's a step-by-step procedure to find the distance. But it also happens to be an abstraction because it is this function getDistance is a simplification that we're making, which masks a complex procedure underneath a name that makes it easy to refer to. So your natural question might be, are all abstractions just names for algorithms? And that's not the case. We actually have some other abstractions that help us simplify the structure of our code as well. So one of those abstractions is this class right here, the bomb class. So when we're playing the game and I'm creating bombs all over the screen, all of those bombs have identical behavior. They have to sit there, they have to check to see if they're close enough to explode when the enemy is nearby, they have to delete themselves and the enemy from the game, they've got to play a sound effect when they do that, they've got to do a lot of things. So it's actually a really complex object, that bomb. But by defining that bomb as a class, that is an abstraction that allows me to simplify the structure of my code. Because when you have a class for something, you can create new instances, new examples from that class that have all of those complex features. So rather than have to go through this complex process of defining what it means to be a bomb and checking the distance and la la every single time you create a bomb, by having this cookie cutter template, every time we make a bomb, we can just use a simple line of code. Let's see if we have it. A simple line of code. Let's just see if we can find it. A simple line of code here, which creates a new bomb that shares all of those features hidden within that bomb object, hiding the complexity underneath the simplification of it being a bomb. All right, so if your code has an algorithm that contains two subalgorithms and an abstraction of your own design, you're good to go. Now, in order to complete your create task, there are three components, which are your individual video. So you're going to record a video of your program running. You're going to write some written responses about the process of coding and also about the choices you made as you were coding. And then also you're going to include your program code with a couple of things boxed and put in ovals. And I've got some other videos describing those, so that should really help out. But hopefully this is a broad description of the create task so you can get started if you were finding it difficult to start before. I hope this helped. Please email me any questions that you have as you begin. Bye.